Hello all. A bit of a change in direction now, I think. I'm not going to be talking too much about hard science, but more infrastructure and facilitating good science. So AuScope Heat Flow Program to upgrade Australia's heat flow infrastructure. I'll acknowledge my co-author, Tim Rawling, who's not here, but he is the CEO of this organisation, AuScope Limited, which sounds like a big, important organisation. It's really just Tim and 2 or 3 people who work in the office with Tim. But Tim manages hundreds of millions of dollars worth of investment money from the Australian government into earth science research infrastructure. So I'm glad to have Tim as a co-author, because that implies he's very strongly backing building Australia's research infrastructure in the heat flow area. So these are the introduction slides for AuScope, Australia's provider of research infrastructure to the Earth and geoscience space community. And that's not just hardware infrastructure, it's also people to run the instruments and IT infrastructure as well. So large computing facilities, software development, and as well as sort of geotechnical laboratories and so the whole package. Lots of AuScope ties together all the state government research organisations, the federal government research organisations. If you know of Australia, you have probably heard of CSIRO, Geosciences Australia. Each of our 7 states has its own state geological survey, and AuScope ties all those government organisations to a whole range also of partner universities in all the different states, as well as, so I'm from Melbourne down here, and spend most of my time at the University of Melbourne. But AuScope ties together all the other states and territories as well. We'll skip over that one. It's just the AuScope marketing slide. So a bit of history about Australian heat flow research. Apologies if there are people in the room who have done research in Australia that are not named on this slide. I'm sure you're out there. And this is by no means an exhaustive list of heat flow researchers in Australia, but basically goes back to the early 50s when Alan Beck, a founding member of the International Heat Flow Commission and one-time chairman of the commission, one of the earliest heat flow workers in Australia, did his PhD under John Jager, another former member of the International Heat Flow Commission at ANU. John Sass came down to Australia for several years and did a lot of work through the 60s and 70s as well. Ron Hindman, another International Heat Flow Commission member, and through to Jim Cull, my PhD supervisor, who was an International Heat Flow Commission member as well. So we have 1, 2, 3, 4, 5 IHFC members before myself and Derek, and we've also had Klaus Regner-Lieb in recent years as an IHFC member. So Australia's been involved right from the beginning in the International Heat Flow Commission. But sort of good to say that Australia's been involved, but when you look closely at it, it was really the Australian National University was involved in the International Heat Flow Commission, and for about 35 to 40 years, it was really ANU who owned all the instrumentation for heat flow in Australia and was doing all the heat flow work, either directly or in partnership with other associations in Canberra, primarily the Bureau of Mineral Resources. So it wasn't until the late 80s, really, that Jim Cull managed to escape Canberra, come back to Melbourne and Monash University in particular, and build his own heat flow temperature logging gear, divided bar, and take on a young PhD student called Graeme Beardsmore to start working on heat flow. So we broke out of the Canberra bubble, as we call it, but still feel the tension building. Batteries. Yeah. Next slide, please. That's not working. I've broken it. It does have an error message on the screen. Aha, thank you. So heat flow research for decades was run through the Australian National University, and then from the late 80s through the 90s, Jim Cull group at Monash was running heat flow measurements elsewhere around the country, mostly around Victoria though. But in the early 2000s, a geothermal energy industry began to develop in Australia, and to support that industry, Geosciences Australia put together a set of field equipment, temperature logging gear, and bought a divided bar, and carried out a heat flow measurement program over a 5-year period around the country, and put out 5 publications overall. 53 new heat flow determinations spread all around the country. But at the end of that 5-year program, the equipment got parked in a shed somewhere and has never been used again, which is a fairly typical story, because a similar thing happened up in Queensland, again stimulated by the geothermal energy industry. The Queensland government, they didn't build their own equipment, but they paid a contractor to make another 10 heat flow determinations. The government drilled specific boreholes for those heat flow determinations, paid a contractor to come in and measure the temperature gradients and the thermal conductivities, and put out a publication listing those 10 new heat flow determinations. And then the program ended, and that was the end of that. A very keen individual in the Victorian government took it upon himself to run again a 5-year program to build a heat flow map of Victoria, and the Victorian government built its own temperature logging equipment and paid for a whole bunch of thermal conductivity measurements, put out 5 publications, 184 new heat flow determinations. It's incredibly productive. This is all mountainous area out in the east here, so very few boreholes to log. No new drilling. This was all in existing groundwater bores and mineral holes, and using BHTs and things. But 184 new heat flow determinations. At the end of that 5-year period, Dave Taylor, the individual of the government, actually retired, and the temperature logging kit got put in a shed and never used again. So this was becoming a bit of a routine, that all these little sporadic heat flow programs, and nothing at a national level that really tied it all together. So AuScope, 2019, I think it was, AuScope was working to develop its new 10-year strategy and 5-year investment program, and convened a meeting of a whole lot of earth science researchers in Canberra for a day to brainstorm how AuScope should spend all its infrastructure investment money over the next 5 to 10 years. And heat flow came out as a topic at that meeting, and with a recognition that there's lots of really good modelling capability in the country now, high-powered computers, very sophisticated numerical modelling packages, and no hard data to actually calibrate those packages or make sense of them. So got very, very strong buy-in to have a nationally coordinated heat flow infrastructure program that included laboratories, field equipment, but also the IT and the people to actually run the programs and make sense of the data and store the data and make the data available to researchers. So I put up my hand to coordinate the heat flow program, and we got a consortium together of 6 universities, a state government association, and the 2 main federal research organisations, CSIRO and Geosciences Australia, and put together a proposal which has 5 parts. So heat needle, which I'll have a couple of slides on at the end, active distributed temperature sensing systems, fibre optic cables with an embedded heating coil in it for in situ deep borehole thermal conductivity and temperature gradient measurements in situ, aquifer thermal energy storage research, marine heat flow sensors and probes, and new petrophysical equipment and databases. So we proposed, I think it was a $9 million program. One of the collaborators has since moved from Monash University up to the University of Queensland. So it's now instead of Monash in the consortium, it's University of Queensland, and the individual from the Geological Survey of South Australia retired and went out into industry. May well find another individual from that state government organisation, but I'm sure we'll be able to rope in other state government organisations. So AuScope went away, wrote their 5-year investment plan, and came back with a well-defined heat flow program with suggested $3 to $7 million of Australian dollars, and that's today about 2 to 4.7 million euros of investment for the next 5 years, beginning 2024, so not yet. And it's about half of what we had boldly proposed, but we were very, very happy to get that amount in black and white in the 5-year investment plan. So some money specifically to develop new sensors, tools and testing sites, cultivate a collaborative heat flow research community, and well, it's not written here, that includes international collaboration as well. And in fact, it's a strong focus to be closely linked with the heat flow community around the world. Hence why AuScope paid for my trip over here. AuScope has already begun dripping some money into heat flow infrastructure in anticipation of the larger investment that's still to come. So in 2019, AuScope committed several $100,000 to put some permanent fibre optic cable sensors in boreholes around the country. So this was the first one installed, which involved CSIRO, putting an active DTS cable into a 500-metre borehole out in a quite remote corner of the Northern Territory near the Queensland border, if you know Australia. That was a very underexplored part of the country. The borehole was drilled as a stratigraphic hole just to see what was there. So it was very much an opportunistic spot to put a cable. Why we want a permanent heat flow sensing spot there, we don't know yet. It was, it was just opportunistic to work with Geosciences Australia and CSIRO to put a first cable in the ground. But it's a permanent cable. We'll just monitor the temperatures and thermal conductivities, and one hope is that we can actually learn stuff about the aquifers that are flowing through there. 5 minutes? Cool. So it's 2019. So it's just some close-ups of, as you see, it's not anywhere near anything. It's about one of the furthest spots you can get from anywhere in Australia, I think. I haven't actually been out there myself yet. I want to take a student out there sometime soon and just reattach the instrument to the top. But this was the first temperature log that was collected just after it was installed, which was now, 7 months ago or so. So in 2021, AuScope handed out a little bit more money for to build a marine probe, and I believe there is some link between the University of Tasmania group and Bremen University, who's in the room, I believe. And I think the University of Tasmania is aiming to replicate a very similar marine probe to this one from the University of Bremen for deployment on the CSIRO research vessel, RV Investigator, and also Australia's soon-to-be delivered new icebreaker Antarctic research vessel, the RV Nuina. So I was putting this slide together. It sort of reminded me of my very first heat flow outing, which was to Rabaul in Papua New Guinea in late 1990, well before they had anything like occupational health and safety matters to worry about, I think. So I dressed up for the photo. I was the only one wearing a shirt, I think, on the day. And it was fun. It was sort of a month chugging around Rabaul Harbour, dropping this hammer-driven coring tube, which would bring 5 or 6 metres of core up to the surface. And then this was my thermal conductivity measurement bench, measuring thermal conductivity of the mud every, I think it was every 20 centimetres with a needle probe. So with genuine 1990 IT technology, but good fun. And coming up, starting next week, I have another 18 months worth of preliminary funding from AuScope to do a bit more preliminary work, install more permanent fibre optic and DTS sensors in boreholes around the country where Geoscience Australia is drilling, implement a national digital repository for heat flow data, so both for existing heat flow data, but also more importantly to hold the data that the new infrastructure is going to be producing, the new marine data, the new DTS data, new just conventional borehole temperature logging data, but to build a new national heat flow database to link with the international heat flow database and be findable and accessible and reusable and useful for people, because you don't know who is going to use this data, as I've recently found out. Review all existing Australian heat flow data for the new global heat flow database. I actually have funding to hire a student or a postdoc or someone to actually rework all the legacy Australian heat flow data into the new database structure. Work with CSIRO to develop some visualization and interpretation tools for heat flow data, make them readily available online, and some money to test heat needles for measuring surface heat flux at critical zone observatory sites. So a heat needle is it's sort of like a marine probe, but for continents. So we hammer this 1 metre long stainless steel tube, slip a set of 7 very finely calibrated and precise temperature sensors, little thermistor sensors, but built onto their own little boards, so there's no interference with copper wires and things for the resistance. So sub-millikelvin precision, and with very careful calibration, we can get about 5 millikelvin absolute accuracy on the sensors as well. So 7 of them. These are actually photos taken from a field trial in Mexico with Orlando's colleagues over in Mexico back in 2015. And here's the sort of data that they put out. I have one more slide, Niels. It's almost done. 2 more slides, Neil. Almost done. So they also have an active heating coil in them. So they're a 1 metre long needle probe as well for a transient thermal conductivity measurement in situ, and measure through time. So we get thermal diffusivity and thermal conductivity as a time series as well, which has actually been quite interesting to look at the top metre of soil and how thermal properties vary. This is my last slide. So turns out that heat flow through the top metre of soil is very, very interesting for soil scientists. So one of the first collaborations from next month will be to collaborate with another nationally funded research group that's looking at soil science and trying to quantify the thermal flux in the top meter of soil for energy balance of an eddy covariance measurement. I have no idea what that is, but it's got the soil scientists very excited that they might be able to quantify the heat flow in and out of the soil. And that's it. So exciting times ahead, I think, for Australian heat flow in the next 5 years.